The second part of customer review analysis, we are going to understand data set and going to pre-process the data set, followed by we are going to do EDA, right? In the EDA part, we will have a graph visualization of the data set to understand it better way. Yeah. So for this purpose, we are downloading data set from Yelp, right? It's called Yelp review data set. So this data set has almost 10 different columns, so which includes business ID, date of that review ID, stars. So we are going to consider this stars as our review. So higher the star, how positive it is. For example, here it can say 5, which means this review is positive. Let's say if some review is saying 1, in that case, we consider that as a negative. Followed by review text, and then type of this user ID and how cool it is, how useful it is. They have some classifications. So we are going to consider only review text and then stars, because stars is going to be our class. Okay. So we have downloaded that CSV and uploaded here. Okay. So first we are importing pandas library to read this data set. Now our data set elf.csv content is in the variable df. Now you can see the same structure, right? So business ID, date, review ID, stars, and text. So now we are going to consider only these two. We don't need any of other columns, right? So now we have loaded our data set into this data frame here. Next, we are going to clean the text data. As I said, this text data may have unnecessary HTML tags. They may have unnecessary stopwords. We are going to remove all those stopwords and all the HTML tags. Right? So here I'm writing a functions to clean the text. Let's see one by one. In this, for this particular operation, right, cleaning operations, we are using two main library. One is NLTK and other one is regular expression. NLTK is the external library that we need to install it. Since I'm using Colab, we don't need to install this. NLTK means Natural Language Toolkit. From that, I'm importing stopwords. So this stopwords consist of all the articles, conjunctions, which we don't need in sentiment review analysis, right? So this function will do 6 cases. So in first scenario, in the first step, right? So once it receive the text, raw text, it will remove all the HTML tags, right? So anything that comes between this open and close tags, it will get removed, and it will remove all the special characters. So except lowercase alphabets, uppercase alphabets, and space, it will remove everything and replace that with just a space. And then it is converting everything into lowercase, followed by we are splitting a sentence into word by word so that we can remove all the stopwords. So we are processing every sentence and every word. If that particular word is in this stopwords, we are removing it. Finally, we are joining back the text list into proper statement. So we are passing this text to this function, and then we are getting cleaned list. So we can see the cleaned list here, right? So it started with my wife took me here on my birthday. So we removed that my on and all these things. So we have this proper text. So there is no HTML tags, there is no special character, no stopword. So once we clean the text, we are checking for missing values, right? If there is a missing values, we need to remove it, right? So to check this missing values, we have this is null values, and also we are checking the total missing value for each columns, total missing values for each columns. That we can see it, there is no missing values here, right? If in case if we have our missing values, we can either fill it or we can drop it. Since we have more data, so we can easily drop the missing values. So df.drop NA will drop all the missing values. So once we dropped all the missing values, we are checking for the shape of this data. So we have a shape as 10,000 comma 11, which means there are 10,000 rows and 11 columns. Also, we need to use df.describe, right? So this will give you a descriptive analysis of numerical columns. There are only four numerical columns. Out of that, we need to consider only stars because this is what our labels, right? So there are 10,000 columns, 10,000 rows that you can see here, and the average value of or the mean value of that particular column is 3.77, and 50% of the values are less than 4, right? So which means 50% of the values are less than 4. So 25% of the values alone are greater than 4. So 5. So maximum 75% of the data are less than 5. Right? So now we are getting into EDA, exploratory data analysis. It is nothing but we are going to analyze the data set with the help of charts, right? So I'm going to use two main library. One is matplotlib and seaborn for this EDA, right? So first step is to draw the graph distribution of stars, right? Distribution of stars. And we can see that, so we are using sns.count plot. Inside that we are interested only in the stars column, and then we are presenting this df. And we also mentioned the figure size of 10 cross 6, right? And then we have ordered the x label, y label along with the title. So you can see, right? So total 10,000. Out of that, we close to have 3,000 plus data are 5-star. Apart from that, everything is 4 and 3, right? So here you can also see that the data is completely imbalanced, right? So if we take positive and negative, right? So if you consider all the 3 stars, 2-star, 1-star, it's a negative data, and 4 and 5, then you have, right, negative data are almost close to 3,000, whereas positive data are close to 7,000. So it's completely imbalanced. So when we process this data set, we need to either balance the data set or we need to limit the positive cases. Okay. In the next graph, we are again doing a distribution, but this time we are doing a distribution of review length, right? So we are taking a sentence length, right? And we are drawing a histogram of that particular sentence. And you can see most of the statements are, right? You can also see most of the statements are close to 1200 words. So each, mostly you can see that, right? So from review length, sorry, we can see that from 0 to 1500. Out of that, you can see sentences with 300 or 400 are more often repeated. So on an average, we can consider the length of the review is close to 400, right? The next graph, we are going to plot the more common words, right? More common words used in this, right? And that frequency. So we can see good is more often used, so close to 6,000 times they use this, 6,500 times they use the word good, place, and food. So these are the top three places, right? So they also use don't. So we can consider that is a negative word. Don't is used, right, in the review. Okay? So these are the top words, right? So you can say these are the top 20 words used in the review, right? Again, so what we are considering here is, as I said, we need to split the data set into positive, negative, right? There are two ways that you can process this sentiment analysis. Either we can consider all those 5-star as it is, like 3 being a neutral, 2 being a negative, 1 very negative, 4 positive, 5 very positive, right? You can have a 5 star or 5 class objects, or you can also combine that stars into two portions, positive and negative. So I'm doing the second scenario. So what I'm doing is I'm creating a new column called sentiment, in which we are processing the stars column. If the stars are greater than or equal to 3, then we consider that as a positive. Less than 3, consider that as a 0, which means negative. In that case, you can see we have one sentiment. So 3 and above are 8,000, right? And 0, which is negative scenario, we have close to 2,000, right? So it's completely imbalanced data set, right? So we are going to take widely used positive words and negative words in both the category, and then we are generating a word cloud. Okay. So here you can see that, right? So in the earlier case, we have taken top 20 words. Irrespective of categories, we have taken all the top 20 words. Whereas here, so we have two category, positive and negative category, right? So the system does business which got one less one or zero, we consider that as a negative, greater than or equal to 3 are positive. And these are the words that are used. These are the words that are used in the positive reviews, and these are the words that are most commonly used in negative reviews. So this we call as a word cloud. This we call that as a word cloud. Okay. So based on this, we have clearly understood that there are data imbalance, right? So for that, we are dealing something, right? As I said, either we need to do some data balancing stuff, or we can extract a limited data from each category. So that's what I'm doing here. Again, less than or equal to 3, I'm considering as a negative scenario, which means if it is a 3 or 2 star or 1 star, I'm considering 0 negative. Otherwise, I'm considering positive, right? And from each category, I'm taking 3,000 data, 3,000 data for negative category, 3,000 data from. So instead of processing 10,000 rows, I'm taking only 3,000 from negative, 3,000 from positive. In this way, I'm constructing a balanced data set. Okay. So before we do our splitting, we can see the top 5 rows in our balance sheet. There are a lot of columns now. One is cleaned text, which is our X, and then we have stars, and then followed by our sentiment here. So we are going to consider this column as our label. Now we are using a sklearn model selection, in that we have a train test split method, which will split the data set into two portions, sentiment data into two portions, training and testing. So here we define X as clean text, and then Y is our stars, because we now have a stars, or you can, here we have now column called sentiment. So we can consider the sentiment column here, right? So X and Y, and the test size is 0.2, which means 20% of the data will be considered as a test data, 80% of the data will be considered as a training data. Okay. So now we have our, so now we can see shape of all the three keys. So original data is 6,000. Actual data set is 10,000. From that, we extracted only the balanced portion, which is 6,000. And then we have a training data of size 4,800, which is 80% of this 6,000. And then 20% of this 6,000 is 1,200. So we have, this is our final data set that we are going to process.